Hi everyone, welcome again to Electronics with Professor Mughal. Firstly, I want to thank all of you for subscribing and liking the channel. I now have more than 1,000 subscribers. I never thought when I started this last year that I would get so much of support from you guys. So thank you again for subscribing to the channel. And if you haven't already, please spread the word, tell your friends about the channel and the scope of the channel. So without wasting much time, this is actually part 2 of the seminar series where I'm inviting speakers from the industry, and today's speaker is also a very interesting one. By the way, if you haven't watched the part 1 of the seminar series, I strongly recommend you to watch it because you're gonna love it. Today's speaker is Arash Nejad. He is actually a power systems electronic engineer, and he is going to share his engineering work experience at Triumph, which is and they're into like aerospace. They're into like helicopters and stuff like that. So I hope you're gonna enjoy this talk. So without wasting much time, let's get started. Dr. Arash Nejad. He did his master's in power electronics. He did his PhD in electrical and electronic engineering from Florida International University. He graduated in 2013. He previously worked as a principal technology engineer at OSRAM, and he's now engineering manager at the Triumph Group. So I'll leave the floor. Please give him a warm welcome.
Ladies and gentlemen, thank you, Masood, for introduction. My name is Arash, last name Nejad. I raised in Miami, and I went to school over there, and I joined, after I graduated, I joined a company in California, in a startup company, which they do wireless charging that right now you have it in your Apple Watches. And then I joined the University of North Dakota as a faculty. So 3 years ago, I came to this New England area. I was working for OSRAM, as Masood said, as a principal engineer and now an engineering manager at Triumph Group. We do a lot of aerospace designs, whatever goes into the aircrafts, into military or commercial, starting from engines or all the way to the actuation systems, canopies, you call it. So a lot of things related to these aerospace products we manufacture. So I'm not sure really what we're going to talk about today, but so I would leave it in kind of like a question and answer, question from your side and answers, if I can answer your questions. I have a little presentation that mostly we use it for our marketing stuff, that you get a little bit more, better insight into what are the products that we're talking about and what kind of an aircrafts and helicopter, what kind of avionics stuffs and vehicles it goes into. And why electrical engineer? I think that's the reason, that's the first question that I need to answer. A lot of you, as Masood told me, a lot of you are a little bit hesitant, or you are not 100% sure if electrical engineering is the right choice for you guys or not. It's a little bit hard to answer if electrical engineering is a good field or a good field of a study for you guys, because from me, I cannot comment on that because I'm an electrical engineer myself. So I'm a little bit biased towards electrical engineering. So I would say, yeah, electrical engineering rocks. All of you come to electrical engineering. So, but what I can tell you, I have only one brother. He's a mechanical engineer, and he is, we both grew up in the same family, but we're completely against each other in almost everything. So he's a mechanical engineer, he hates electrical engineering. I'm an electrical engineer, I hate mechanical engineering. So once back in time when we were both in school, always we had these arguments with each other that I was telling him, hey, you know what, you're in a field that it's dead, it's old. Mechanical engineering is 200 years old, it's useless. Everything is going electric nowadays. And I was making examples of electric vehicles. Look at Tesla, look at, Fisker, other startups for electrical vehicles. But honestly, after all these years, I figured out that indeed, mechanical engineering is not dead, civil engineering is not dead, electrical is definitely not dead. And this aerospace field taught me one thing, and that's only this product that is flying is a combination of the works from mechanical engineers, from chemical engineers, from material engineers, and electricals together. So without each others, we could never succeed. I was thinking, okay, what is these mechanical engineers always doing? All they do in design is a little gears. That's it. Just they don't do better than that. But actually, this is a lot more complicated than what I thought. Because so far, all the companies that I was working with was the stuff that at least the R&D things that I've been working for. They were like pure electrical. We didn't care about packaging. We didn't care about cooling. It wasn't very efficient. But nowadays, I'm seeing that, oh, actually, you know what? It's much more complicated than I used to think. And just as an example, here I have a couple of things in this one. So this Triumph group, back in time it was called Fairchild. We have several divisions all over the country, and we are located in Connecticut, in Hartford, Connecticut. So what they do here is that integrated systems is our divisions, which is, our job is to basically to combine to produce systems that they go into another product, that product is eventually going to the aircrafts. We have other divisions, Aerospace and Structures, but they are based on Windsor, Connecticut, which they do whatever is related to the body of the aircrafts, frame of the aircrafts. And then product support, which has, just like many other companies, we do have a product support for our stuff. So what are our systems? Here is an example of what we manufacture, and it's very hot these days in our company. We call it electronic engine control system. We call it EEC. So what does an electronic engine control does? Very simple, isn't it? Electronic engine control. What does electronic engine control does? Can you help me?
I'm assuming it controls the function of the engine.
Excellent. That's it. It's as simple as that. It controls the functionality of the engines. What kind of a functionality of the engines has? You help me again. Yeah, what kind of an engine? What functionality? It's about an engine on the aircraft. What is it? Produces thrust, exactly. How does it produce thrust?
Sort of like there's a type of when it pushes air in.
Exactly. So what do you control to cause that? Imagine that you want in your car, in order to accelerate, what do? You press the pedal, right? And what the pedal does, it opens some sort of a valve, and then the fuel gets into the engine, to the cylinder, and you burn it, and then what happens next and next and next, right? So the same concept is on aircraft, right? So the engine is a functionality is different, right? As a turbofan engines, it's different, but it's still the conceptual thing is that it's a combustion engine, right? So you inject some sort of fuel into it, you burn it, and it gives you thrust, right? That pushes the aircraft. So here, that little thing that you see over there is what controls how much fuel you have to inject into the engine. Just imagine an aircraft has multiple. It has most of them nowadays. They have at least two engines. Some of them one, some of them two, some of them four, right? And but there is a big difference between aerospace and your vehicle. What happens if your engine in the cars stops functioning? You pull over, right? What happens if the engine on your aircraft stops functioning? You crash, right? So that's why your engine in your car doesn't need a big box like that, but the engine on your aircraft needs a box as big as that, right? Which is very complicated. And that's something which is, we call it what? Those items that goes into aircraft, we call them mission critical components. What does that mission critical components mean? Mission critical means that if it doesn't function, you're going to crash, right? If you have other products that is not very mission critical, right? Like what? Can you make me an example?
Cup holders.
What is that?
Cup holders.
Cup holders. Cup holders are not. If your cup holder crashes or stops functioning, what would happen? Nothing, right? But cup holders are not necessarily electrical components, is it? Unless it's an advanced cup holder which heats up and cools down your drink, which is electrical. Go ahead.
The infotainment system, like in an
Entertainment system.
Yeah. Like
Exactly. If your entertainment system stops functioning and you cannot watch a movie during your flight, you're not gonna die, right? Some people they would, but I would die if it's a 12 hours flight and the entertainment system is not working. But so another products that we have, and right now we are focused on, is called thermal systems. So what is thermal systems? What is a thermal system in an aircraft in general? Make an example. Refrigerators, right? Refrigerators is a thermal system, isn't it? it gets the heat out of a product, whatever you have in your refrigerators, and give it to the air, to the ambience, right? It's a thermal system to the refrigerator. Is it mission critical? No. So what would happen if your refrigerator fails? Your food, your drinks in the aircraft gets warmer, right? That's it. So probably the levels of, we have something we call it design assurance level. What does design assurance level means? Means that you have to make sure at what level your product is reliable, right? So the highest level is 7. We call it DAL, design assurance level. DAL 7 means that your product is very, very reliable. It doesn't fail. If it fails, it has backup and so on, right? And that engine control is one of them. If your refrigerator fails, nothing is going to happen. So we don't really need to have such a huge reliability. If it's a DAL, I don't know, B or C is probably sufficient, right? And and every single thing. So higher level in the design assurance level. Let's say these DAL A or DAL B means what? Means higher investment in it, right? To get reliability. It means more tests, and more tests means more labor. More labor means like what? Means more money to the company, right? They have to invest more. So here I have 3 pictures. One of them is fuel metering. So that's a typical picture for the fuel metering system in the middle, which shows that's pretty much clear, isn't it? So how much fuel is left in the tank? The other one is fuel electronic control, which we just talked about it. The main fuel pumps, what does it do? The same thing that a fuel pump does in your car, right? Injects fuel to the engine. So here we got some sort of a game. So are you familiar with these aircrafts? These helicopters on the top. Some of them you probably know them, right? What is the? I don't know a lot of them. I keep forgetting things. So this is kind of a product. These bottom things are all engine control units. They control engines. But what kind of engines? They are helicopters. We are mostly having they are single turbo shaft engines, right? That top one, at least the first one, UH-1. And if anybody have seen the UH-1, probably have seen. Anybody have seen the movie Full Metal Jacket? That's shows the Vietnam War. That aircraft is shown a lot in that movie. What type of aircraft do you think it is? What is the manufacturer? I'm not sure, but probably you can Google it. UH-1, probably it is a Bell, maybe. Is it? You don't know? Google it. Who has a computer? Oh, everybody, all of you have phone. Nowadays you have these things on your hand, on your wrist too. Is it a Bell?
Yeah.
That's a Bell, right? The second one, AH-6. AH-6, I think it is a, I'm not sure, probably Boeing. Is it a Boeing? So how about the third one? That should be another Bell, I guess. And it's a single engine, 4-propeller air helicopter. Is it a Boeing?
It's a Bell.
Is it a Bell too? Oh, okay, interesting. So how about the third one? You all know that the fourth one, I'm sorry, AH-64. Do not Google it, try to say it, make a guess. Come on, you all know what is that. Apache, very good. It's very popular. How about the fourth one? There is a movie out also based on the fifth one, I'm sorry.
That is CPOM.
Say again?
CPOM?
Very close, very close. There is a movie called Something Down, what is it? Black Hawk. Yeah. How about the seventh one? That's huge. That's it can also lift a huge weight of cargo. What is the seventh one? CH-47. Last year we just fixed one of them and flew. What is that? Chinook, right? Is it Chinook? Is it what company is that? Is it McDonnell Douglas or what is it? Boeing. Oh, interesting. I didn't know that. The eighth one. I have no idea. I don't remember. That's CH. It might be another Chinook, right? CH-53. Sikorsky, oh, that's the Sikorsky. Sikorsky is another aerospace company, actually. They are also located in Hartford, Connecticut. So two states, amongst the rest of them, they have the highest density of aerospace company. One of them is Connecticut. The other one is, who knows which one is the other one? Where's the location of Blue Origin, Amazon, or SpaceX? Which state? Say again? No. Washington. Very good, very good. The state of Washington. So they're mostly located in Seattle. So, but actually, you said SpaceX California. SpaceX has facility in LA too. Nowadays they have facility everywhere. But it's like saying that where's the headquarters of UTC? I don't know where's the headquarters of UTC, but I know that the UTC, probably Texas. But I know the UTC and the Rolls-Royce and others, they have a facility also in Connecticut. And that last one is, which I have no idea what the name is. It's an Indian helicopter, so they're servicing the Indian Army and so on. The next one, which I have no idea the name of each one is, but they're only commercial helicopters. So the previous one was military. This one are commercial, and some of them I know, like that cool one, H-160. I know that is if I'm not wrong, a Boeing helicopter. And the first one, that tiny one, that small one, is a Eurocopter. So it's a European brand. Some of them are Eurocopters, some of them are Sikorsky. That third one is Bell, the fourth one is Bell. So, and the rest of them I have no idea. But mostly, this one is another sort of engine control. So you will see that the functionality of most of them are very similar. But based on the requirement that our customers ask us, we customize this product, each one of these products, we give them a specific functionality. Or sometimes they have to operate at different environments, right? Some of them they have to operate at different temperatures, different altitudes. So it has effects on the package. And sometimes the customers have limited space for that engine control. So we have to design our stuff in order to fit in their limited space that they offer. And
So the Trump makes this engine control system for all of these, or some of these?
for all of this. So all
For
these
all of
products
these, okay.
are stuff. So this bottom row is basically a list of our products.
Ah,
So
okay.
we manufacture all of those things and we sell them. Some of them, we don't sell them anymore. Some of them we still in production. Depends on what was the quantity of each unit. But it's not only helicopters. The other one is aircraft. So that again, military aircrafts. F5. F5. You should know these things better than I do. F5, I think, is it Northrop? That was a Northrop? Okay. Let's see, he knows it. You Googled it or you knew it?
I'm pretty sure it's that.
You're pretty sure? Okay, awesome. How about F-18? F-18 is McDonnell Douglas, I'm pretty sure, right?
Not sure about that.
No? Okay. That fourth one is very interesting aircrafts. That the name has been, I just learned that the name has been taken out of the probably passed away presidents of Vietnam. No, sorry, not Vietnam, Taiwan. And basically that aircraft is manufactured by Republic. I don't know if it's called Republic, but it's called in China. It has been manufactured over there. And we developed the pumps, the fuel pumps for that aircraft. Can anybody tell me that middle one, the fifth one, what kind of an aircraft that thing is? Richard, what is it manufactured? It's very interesting. They used to manufacture cars, and they still do, but they sell it only in Europe. They don't have a market in the United States, in North America. Can anybody tell me what is that? No, Mitsubishi. I don't think it's a Saab, very good. That's a Saab, exactly. They used to do cars, and the cars was made out of the same alloy that they did aircrafts. Yeah, they were big cars, I've heard. And they had actually a model that instead of steering wheel, they had something like a joystick. Have you seen that?
Yeah.
And that was a disaster. That program failed so badly. So, and that sixth one, RQ-4B, you are familiar with that. You have seen tons of movies with it, right? With RQ, unmanned vehicle. That, the two last one, you all know that, right? Don't you? That's one of the biggest cargo aircrafts, which also that can carry passengers. It's called what? Hercules, C-130 Hercules, right? So we do engine control. So look at that. You have four things that goes into that, and each one is doing what? Is controlling the electronics inside of each engine, and there's four engines on it because it's very heavy. The other one, regional jets. So they are mostly, it carries maximum of 100 passengers. They are called regional because they are not long distance. They cannot go too far. And Hyundai, Cessna, Canadair, Avro, ATR, which is another European brands. Challenger as another one, which I don't know what's manufactured of the Challenger. So we manufacture, this is only some of our products, which goes into aircraft. And if you look at that, each one is combinations of, so the pumps is a combination of a hydro things, which is a pump, right? So it's a mechanical thing, and electronics that controls the pump. The rest of them is mostly pure electronics. So the mechanical engineers get involved in order to secure the right packaging for it, right? Okay, and the big aircrafts, so 747, A320, B757, B767, and actually the other big aircraft that we manufacture products for, actually internal system, was A380, which is I think the biggest aircraft, right, passenger aircrafts. And they just, you know that they just retired A380. Anybody knows why? They just announced it in February. Anybody knows why they retired the A380? Nobody have watched the documentary for that? A380, no? Nobody? Nobody knows why the aircraft? Anybody have flew with A380 before? No, they are not. They are mostly in trans-Pacific or transatlantic flights, not regional, not inside the country. It's a huge aircraft, very expensive. So the reason that they retired that was, but it was too expensive, and but Airbus was losing money on A380, so that's why they retired it.
Only Emirates had it, right?
No, a lot of them has. Emirates has, British Airways, Singapore, Korean, France. Yeah, there's a lot of them, and the issue is that the operation cost is too high.
It was the fuel consumption, I heard, was extremely high on that. And that raised the cost.
Extremely what?
The fuel consumption on it was really high.
There's a lot of things.
The maintenance cost and all that.
There's a lot of things. The thing is that in order to, for A380, in order to call it break-even point, so the break-even point is that they have to have at least in each flight 320 people, so the capacity is up to 550 passengers. So the break-even point is 300 passengers to break even with the operation costs. And so the rest of them, is like leftover is like 200 passengers. That's the profit.
Yeah.
So they could not guarantee to fill that gap all the time in order to be profitable. But it was still in operation for around 20 years. But the lifetime for that was pretty rough, 30 years.
Before you continue, can I ask one more question? Absolutely. What are the major components of engine control system?
So there's a lot of things. The main and the most probably important thing is the processor. Okay. As in a lot of products, right? Mm-hmm. So our processors are mostly, we use DSPs, digital signal processors, or we use FPGAs, field programmers, gate arrays, and I'm sure you're familiar, some say others, but the difference between this and other products is that the DSPs, they have to go through extensive tests to make sure that there is no failure in it. So probably, and they have to follow certain standards, like for example, DO 254, 258 is one of the military standards. You have to make sure that it has to go, all of our products, every single lines of codes that you put in your microprocessors have to follow and be compliant with the standard. Aside from that, then you have A2Ds, you have D2As, you have like everything that an electronic system possibly could come up with. There's just sensors, different type of sensors. It comes with the power supplies for itself, because aircraft supply you with a standard 28 volts, which is always constant and very reliable, and also supplies you with an AC voltage of 400 hertz, but it's not always. But sometimes you need a lower part of voltage. A lot of electronics, microcontrollers operates with the lower voltages, right? So you have to somehow convert that 28 volts, which aircraft's engine is supplying you, because aircraft's engine also is hooked to a generator. So while it's giving you thrust, there is a tiny generator which is attached to it. It creates electricity for the entire system inside of it, right? So that thing, we call it wild frequency. Why call it wild frequency? Because the engine goes at different speed, right? And if the speed goes up and down, the level of the voltage here goes up and down, and the frequency changes. So we call it wild frequency. And what happens is that we have to make sure that it's being regulated inside each box. So it comes with a lot of power supplies, power conditioners, and it's all of these things located on a PC board inside each box, each engine controls. Yeah, and then there are a lot of communication devices inside because it has to record every single event and it has to talk to the aircraft, to the operator. So yeah, so all these things, it makes the package kind of big. So I'm considering this.
The reason I ask you that, you guys will learn all about this in your ECE courses.
Yes. So what do we do? We get the, so in general, this is not necessarily, this slide that you see here is not necessarily for electrical engineering. I was supposed to have to talk for half an hour, right? Something
40
around that.
minutes, 45 minutes.
Okay.
Yeah, 3:50 they're gonna have to leave.
Gotcha. Okay. So this, because I wanted to give some time for you guys to ask your questions. So requirements is the first thing. We ask, what do you, as a customers, what do you want from us? So what is your specifications? And then based on that, we design our stuff. We come up with a preliminary design. Preliminary design means what? Means it's something which is functional, but it still hasn't passed the test standards, the compliance test. And then after that, we go to the detailed design phase. Detailed design phase means that is it right now is the time to focus on those specifications that has been identified by our customers and clients. The last, the fourth step is the verifications, to test it. Go through the extensive tests, exhaust this units, make sure that it passes everything, make sure that it doesn't fail, make sure that it meets the lifetime requirements and so on. And the last, qualification and certification. We certify, that means that what? If something fails, something happens, we are responsible for it. That procedure is pretty much common in most of the products, not necessarily aerospace. So here, research and development, we have new technologies, new tools, new applications for everything we are looking for. We do a lot of R&Ds. We hire people. So keep that in mind. When you graduate, right, it's called Triumph Group. Send us your resume. And so this is a picture of our facility. What we have and what do we do with these. So ECU assembly. So ECU, what does ECU stands for? First slide. Anybody remember? Go ahead.
Electronic control unit.
Excellent. So ECU, we assemble. We have technicians, engineers sitting there in 3 shifts, putting together these things, these tiny electronics bits and pieces. And the next one, the second one, is ECU test. So what we do, after that they're assembled, they will put it into the chamber, we heat them up to what? 120, 150 degrees C, all the way down to negative 50 degrees C. And then we make sure that in those extreme conditions, they don't fail. Why do we do that? Why do we care that our system operates from negative 50 to 100 somethings?
Because, like you said, they're like mission critical. So
Exactly.
You want to make sure.
So have anybody checked out the temperature of the air in the altitude of, let's say, I don't know, 20,000 feet in the aircraft? Sometimes I think Delta Airlines, they have that. What is the typical temperature? Do you remember? Negative 60. Up there is very cold, right? So this stuff is going to fly up there, and there's no air conditioning around it to warm it up. So it has to survive in that temperature, right? And then hybrid development setting. So basically, this is a test rig for our pumps and our other stuff, compressors and things like that. The FC development test is kind of the same thing as a hybrid development test is kind of. High precision machining. You know, sometimes we have a tiny bits of pieces of equipments that we have to make sure that, you know, the tolerance is not crazy. You know, we have to meet bits inside a tiny space that the aircraft is giving us. Assembly and test. Anybody knows about that EMC test chamber? Anybody knows what that thing is?
It looks like something Indiana Jones would find in an ancient temple.
Exactly, that was correct. That's what we do. So what else? I wanted to say in the movie X-Men, you know, I was X-Men movies, the very first time that I saw it, I remember the name of the guy was Magneto, right? In some scene, I think he was dealing with some of these things, if I'm not wrong. I remember something. So anybody no idea what that thing is? I just said that. Magneto, what is Magneto about? It's all magnetic. That guy was magnetic. What?
Is it like an electromagnetic current generator?
No, it don't generate.
Test for like electromagnetic interference to generate?
Very good, very close. A test for electromagnetic interference. What does that mean? Can you elaborate a little bit more? Can you elaborate a little bit more on that electromagnetic test? What does that mean?
Well, they emit electromagnetic radiation, and there are limits on what devices can put out. I think the FCC implements
Yeah, very good. FCC. So anybody, have you ever noticed, if you check your electronics stuff, back of your cell phone, it said FCC symbol on it. What does that mean? FCC stands for what? Federal Communications Commission. What is their requirements? They said that your stuff has to meet certain electromagnetic behavior, right? Means what? Means that if I turn on my phone, if I'm talking to my phone, it shouldn't interfere with your phone. It shouldn't interfere with my radio, with my TV, with my computer, right? So because of that, we have to have a test chamber like this, which evaluates, which kind of model and emulates the open air for us. Those things, those cones on it, is called absorber. So it absorbs the electromagnetic fields, but therefore you don't get reflection from it, right? So it's very needed because if I test my stuff in an open air, first of all, I get a lot of interference from outside, right? So I test my equipment in this room. There is a cell phone tower next to this room, and then it interferes my results. It penetrates to my antenna, and then I get crap, which doesn't belong to my products. So it has to secure inside that box that nothing crazy is coming from outside, but also I do not get reflection of my own things on my products. And then electronic development, which is mostly for R&D, which all of manufacturing R&D centers, they all have something like this. So it's not only unique to us, but ours is kind of unique because the kind of things that we are doing is kind of cool. So I came from I work in a cell phone company. I came for an LED lighting company, and amongst all, so even before joining here, I was supposed to join another company. But then when I joined here, I noticed that this is so cool. This is something that I used to draw. I used to do painting and drawing and sketching aircrafts when I was like a first grader, and I never got into a job like that. And then after that, after 30-something years, I went to the company. First time that I interviewed this place, I noticed that, oh, you design stuff for a canopy. I've never been in a canopy of an F-18. Just I want to see how it feels. So, and it feels really good, guys. It was really good for, the pilots, they said that they have the best job in the world. This is so true. So, I'm done with my talk, and it took half an hour. Sorry about that, guys. I talked too much. So, I think, sometimes in these kind of meetings, in these kind of classes, I always get bored. Because the instructor always says stuff that I don't care. I don't care what this guy's talking about, and he doesn't answer any of my questions. So, I'm sure that I haven't answered probably 90% of your questions. So go ahead, just feel free. You don't need to raise your hand. Just go ahead, jump in and ask. So why are you hesitant from electrical engineering? Isn't it so cool? Okay, so one person. Who else? How about you? What do you think? You're pretty quiet. Say again? I'm a little bit.
Usually very quiet.
I'm very deaf. I'm sorry. That's your problem. You got to speak louder. So we come back to you. You say something. You ask.
I'm hesitant because I'm worried I won't be able to do everything that I'm learning. Like I won't be able to remember what I'm actually doing and apply it outside.
Oh, interesting. So, like what? Can you make an example?
Like, I think it'd be really cool to build satellites, but I cannot see myself building satellites even if I learned how to do that.
Why don't you see yourself
I
building
don't
a
know. I
satellite?
feel like I'm not capable of getting to that point.
What kind of a capability do you think it's needed to build
I'm
a
not
satellite?
sure.
Okay. So then if you're not sure what kind of a capability is needed, then why do you come up and judge yourself?
I don't know.
I think the capability that all you need is passion.
Yeah.
If you're passionate enough, means you have a capability, right? It's like a games. You will succeed in something that you enjoy. If you're not enjoying something, no matter how cool it is, no matter how other people are talking about it or how much they pay, you're not going to succeed. You have to quit. So the only ingredients that you need is passion. That's it.
Yeah. Never underestimate yourself.
Exactly.
Yeah. You will be a completely different person after 4 years. This is just the beginning, right? So.
So next person, you say something.
I don't know. I'm considering EC, but also computer science. So,
Oh, by the way, computer is a big thing. I forgot to talk about computer. Nowadays, cybersecurity is becoming very important. Why cybersecurity is very important? Because they hack into it. They hack to our system. They make it crash, or they steal information. Information these days, guys, are money. right? So if somebody else gets into that, steal those information, they can extract out. They do crazy things. So all of you guys, they watch what? Who would ever think that Facebook would become so important that some people, some foreign countries would ever invest in a Facebook? To me, Facebook is always something to post bullshit pictures in it and nothing. So drunk people would post their pictures on Facebook. But indeed, some people, they can use it, right? They can abuse it sometimes. So the same thing is in an aircraft system. You know, when I was thinking here like a thermal system, a refrigerator, things that cools down beers and wines in the aircrafts. How important is that? But actually, it seems like it's pretty important because you know, right now they're talking about cybersecurity on the processor that is on the thermal system, on a cooler, on a refrigerator in an aircraft, because that thing is connected to a lot of other things in aircrafts that if somebody can hack into it, they can steal information. It's not only damaging things, it's sometimes the tampering, data tampering, mischanging data, or stealing information, right? So a computer thing is a big thing. We cannot work without computer, without software engineers, without embedded system. We call them firmware engineers, those guys who program these little tiny microprocessors, microcontrollers. That's a big deal. So if you're electrical engineer and they said, oh, you know what, I'm electrical engineer, I don't know nothing about programming, then you are not electrical engineer at all. You think you're electrical engineer. So an electrical engineer nowadays has to know and has to learn how to code. If you don't know how to code, you're not electrical engineer, you're not mechanical engineer, you're not computer engineer. So that's a big thing, that's very important. So
yeah, I'm kind of on the same boat as him. I'm also interested in computer science as well as all of this, so it's kind of just like, I don't know, kind of just like seeing, like looking more into it and seeing if it's something I'm really interested in.
Okay, interesting. Okay. And I think in WPI, electrical and computer engineering are kind of joint departments. Right. So you have, it's not like a separate thing. So yes. Probably in your curriculum, you learn about electrical engineering and you learn about computer engineering, right? Yeah. So, yeah, okay, cool. So, you, the guy in green.
I'm mostly wondering how I'm going to get back to my normal state dry.
Computer over here.
Yeah.
Computer, okay.
This doesn't take any electrical engineering.
My umbrella has
Pretty
Wi-Fi.
See, mechanical engineer. That's where this comes in.
Well, his umbrella has Wi-Fi, so it's a little bit of computer.
It tells me when it's raining.
That's cool. Alright, so can you tell us a little bit about your umbrella? How does it function?
Well, it doesn't have Wi-Fi. I may have lied about that. May have.
No. Stick with the lie. Stick with the lie. Keep lying till they believe it's the truth.
Fake it till you make it.
Eventually, yeah.
Okay, interesting. So, why do you want or why don't you want to pick electrical engineering?
I do want electrical.
You do want? Okay,
yeah,
so you're not hesitant. You are already decided.
I'm worried I won't find something I would like to specialize in.
Interesting. Okay. Like what is it like? For example, when you say that finding something that you want to specialize in, can you tell me a little bit about it?
Like analog stuff, digital stuff. Do I want?
Don't look at it. You know, one of the things that I was thinking. Don't look at it. One of the courses that I hated when I was doing my bachelor was electromagnetic, and I got probably a D. First time I got an F in it. Second time I got a D, and I just passed it. I was okay. I was happy with D. To just let me just go. I hated that course so badly, and eventually I got my PhD in electromagnetics actually. So you never know where life would take you. So eventually I came up with a thing. So I was working in a lab that Office of Naval Research, ONR, was a sponsor in that lab, and they wanted initially that I got into it. They wanted to model a line in something, and I don't know what it was, but they just wanted to see what is the electromagnetic signature of electric motors, which is located, let's say, a couple of 100 feet away from it, and how would it look like on that piece of line that they gave us. That's it. That's how much information we had. So it started from there. I started learning a few softwares, and one of them was called Finite Element, that you could really actually plot and sketch the electric motors, define where the cursor gets in and where they get out, and then what is the electromagnetic field in a few meters away from it. So, and then I became interested in it. I said, dude, this is so cool. So I never thought that electromagnetic could be so cool. Electromagnetic was always a shit for me. So. And yeah, but yeah, exactly. So this analog, then you look at it in the form of like analog or digital, and then you don't know exactly what it is, because sometimes our textbooks are like that. They keep talking about a circuit. Okay, what the hell is that circuit good for? Can you give me a just interesting example? I put it in something that actually works. And so if you tell me first, okay, we are talking about electric motors, but that freaking electric motor is supposed to run a car, so probably it becomes a little bit more interesting, right? So if you talk about applications before talking about the freaking circuit, that probably makes it a lot more interesting. So look at it in that way, I think.
Pretty stuff on EC, I just want to learn more about it. So,
Okay. Oh, cool. Cool.
Similar. I just feel like I should learn about it before doing it for the next few years.
Interesting. Okay. Yeah, that's actually you know, you have to learn, but that's the right choice. So that's the right way to do it. So the same thing.
Pretty much same thing. Yeah, what got me into ECU was I really like music, so I play guitar and I sing. And the thing for electric guitars, you can buy effects pedals. Basically, goes between the guitar and the amp, and it changes the sound. So all it's doing is basically each box is a circuit that influences the signal as it goes, and it can like delay or add gain or add reverb or etc. And I find that really fascinating.
I would recommend. I would suggest that you should read about the story behind the story of Dr. Bose. You know Bose headsets, don't you?
Yeah.
Who doesn't know Bose headsets? So he was electrical engineer, I guess, at MIT, and probably later on he was joined as a faculty to MIT. I don't know about that. I'm not sure, but he founded this company called Bose in Framingham, and it's a big facility, and they do crazy stuff, and so. You know, I visited their facility once a long time ago, and so they do brilliant stuff over there. They have a lot of electrical engineers, a lot of electrical, mechanical, thermal engineers. So.
We have a lot of our EC engineers, they are hired by Bose.
Yes.
I'm pretty locked into EC, I'd say, but I'm just kind of wondering what I'll end up getting into. I'm not necessarily afraid, but I'm curious about where like my classes are going to take me and like what specialty I'll end up getting. And I took this course because I thought it would be a pretty good intro to what I'm going to be doing starting next semester and stuff.
Interesting. Yeah. Well, it depends. Always there is a possibility to switch. So I did a lot of, as I said, when I graduated with magnetics, I would never know that I would end up doing power electronics. And when I did power electronics, I didn't know that I would end up eventually doing something else on the business side. So the thing is that you don't expect that your classes will take you to certain things. And if you ended up, let's say you learn about communications, antenna design and stuff. Don't ever think that, because right now in antenna design, that's it. My life would be like always until the end about magnetics, about antenna communications and stuff. No, always, in anywhere in this route, you can switch, you can shift to the different fields. Your magnetic designs, you can do electric motors, you can do electric vehicles. You're doing electric vehicles, you do lighting, you do aerospace. So there's always a need for every single field, so, and you can always switch. Because you have the base, you have the background, right?
I'm pretty set in ECE, and what I'm interested in is like integrating the human body with electronics and
You like the wearable devices, wearable technology?
Yeah,
That's cool.
yeah. And I've always kind of been annoyed because like the human body, like we're kind of blind. Our senses are so limited. There's so many things we can experience. I'd like to be able to experience.
That's very interesting thing,
Yeah.
actually biomedical.
Yeah.
There's a lot of biomedical companies in this area. One of them that I learned a few days ago was Medtronics. They do crazy things with, with artificial hands and artificial limbs and things like this. I don't know. It's called biomedical engineering, I guess, and part of electrical engineering in some department. So, and they do crazy things with human body, and they're very successful. Very interesting. So, how are you? You're the last, I guess. So we do it like this.
So I'm actually doing robotics and mechanical engineering, but EC seems really interesting, so I want to learn more about it.
Did you know that there is a field, actually, combination of mechanical and electrical engineering? It's called mechatronics. Yeah, called mechatronics, which is electronics and mechanical engineering, which is you gain a little bit of knowledge on mechanical engineering, how to design robotic arms and things like that. I don't know nothing about these things. But the electrical side, whatever controls the actuation systems, it's a tiny motors, right? So So you have to rotate it somehow and be able to control it at a certain angles and a certain speed, certain position. So that thing is electronics gets involved. That thing is where electronics get involved. And yeah, that's very interesting. So, and you?
Undecided.
Undecided. Still undecided.
No,
My
undecided.
bad. So, oh, you are decided.
Yeah.
Okay, cool.
The reason I'm decided an electrical engineering company is paying for my college. That's why I'm here.
Okay, okay. You know, that explains everything. So, that's good. So, which company do you work for?
ART engineering.
Say again?
ART engineering.
Everything engineering. Okay.
Yeah, just
What do they do?
mostly on like this electrical engineering, but leaning toward like architectural stuff, like powering hospitals or high schools.
Oh, interesting, interesting,
I got to
interesting.
work on the new sound so.
That's cool. That's cool. That's another field, by the way. I missed to talk about that. A lot of people does this. So probably after a while, your company is going to ask you to get your PE license to sign underneath their things, right? Right there, their design and stuff, because that's what is required. They do offer service to the public, so to the civilian, they should have to be certified and licensed in several things. Very cool, very cool. So anybody, any questions? Something that I missed? Something that you want to talk about it? And something cool? Anybody has a joke or something?
I have a question. Yeah, like one of the things that got me into the electrical engineering field was the idea that it seems to be a base point for a lot of different areas. Like I used to work as a software engineer, and my boss told me don't go into CS, go into ECE, because if you want to branch from ECE into CS, you can do that, but you can't go vice versa. Like you can't go the other way very easily. Right. So like, what do you think about how widespread is ECE? Like can you find?
Well, it depends on your curriculum. It's very high. I don't know how's the curriculum of WPI. WPI is a good college. That's all I know. So when we had a couple of employees from WPI, and they are very smart, very competent, and actually one of them that I remember right now, he's computer science, and he actually does a lot of electrical engineering things. Yeah, and it doesn't mean that you are completely off and you cannot go back. I kind of disagree with that because you always. So what is the difference? How many courses? Imagine that you do computer science, and later on you want to learn how to, again the same example, how to rotate a motor. So all you need to learn to get the basics is to a few books, right? How many books? 2 books? How much time is it gonna take? 6 months. So you get deviated, but within 6 months you can get the base that other people's also. Electrical engineer is there. So the electrical engineering and computer science is nowadays very much integrated. It's really tough to. Maybe back in time, maybe I got into bachelor program 20 years ago exactly. 20 years ago, yeah, because my birthday was 10 days ago. So 20 years ago, almost I can accurately tell you. 20 years ago, I got to electrical engineering program, and actually, it was a little different. We had only, I remember in my curriculum, we had two or three courses only, which makes it 10 credit total for computer programming. We learned a little bit of C programming, a little bit of embedded like microcontroller stuff, and a little bit of computational type of things, which require some C programming as well. And that was it. But now it's completely different. You get a course on digital control, you have to get an Arduino board. I'm talking about a time that there was no Arduino. You were dealing with 8051. Anybody knows what is 8051? Remember 8051?
Yeah.
It's obsolete, it's antique now. Do they still use them anywhere?
Sometimes.
Interesting.
Yeah.
8-bit microcontroller.
It was a 40-pin chip.
Yeah. 40-pin chip, 8-bit. And now you get a tiny processor like this big and it's 64-bit.
Yeah.
So, yeah, well, I'm talking about that time. And so, yeah, and I think it was different. Now it's completely different. You learn how to program everywhere. You do. In your senior design things, you have to build this stuff, right? So you have to deal with electrical engineering. You have to deal. So your computer things have to come up with to move something or program something. That thing might be electrical. So, no, I don't think you are way off, and there's no way back. that one of the words that I always hated myself was the word impossible. That thing is impossible. No, they just wanted to kill the hope. So they don't have hopes, man. They can't do. No, that's something which pisses me off. So in myself, but because actually it's not true. You can't always switch. I know a guy with engineering who went and jumped into like medical things, and he later on became a faculty at Harvard Medical School. Now he's in UCLA. I guess he just left it last year. And he was electrical engineering. Then he got a little bit of medical. And then he combined both and became like a medical engineer active in the medical field. So he does like crazy things, important, very, very top-notch, high-end design, R&D in his lab. So in UCLA nowadays. So what else?
One more minute.
Sure.
One more minute. Yes. I have one.
Sure, go ahead.
So eventually in 4 years of time, they will graduate. So what do you look for in a fresh graduate? In terms of like systems and software, what are those things they need to have good strength in?
Well, you just answered that. Systems and softwares. So learn the fundamentals as much as you can. Be good, enhance and improve your foundation right now. And nobody expects you to, after that you graduate from your undergrad degree, nobody expects that you all of a sudden jumps in and designs something crazy from scratch, right? So you get more deeply into the narrow down somehow your field when you either go further in your education, go for a master or go for a PhD or even postdoc or after that, or get into a company that a company trains you and teaches you how to do things, right? They assign you some task and basically you get feedbacks from your manager, from whoever you're reporting to, or sometimes companies they're like a college. They completely train you on different things. And but what is important here? And imagine that you get into that interview, and what is important is that the first question that I'm going to ask, to make sure that, okay, do you have the foundation? I'm going to build a house on that ground. Do you have the right ground on it? So that's the only thing. So whatever helps with that. Nowadays, a lot of things are becoming software. Back in time, it was manual calculation, right? But now software does this perfectly for you guys. So I think be very careful. Keep an eye always on learn the softwares that does a certain things. Like for example, for the simulation, right? So probably circuit 1, circuit 2, you will have passed these courses that you have to put a circuit and manually solve the circuit and let's say calculate the current or voltage across in a certain component. The software also does this for you. So learn both and then compare your data, compare your results. That's a skill set that down the road would become very beneficial. So
what simulation softwares do you guys use?
We use like tons of them. We almost have every single one of them. But nowadays, MATLAB is the most popular product. I would say, yeah. MATLAB in terms of simulation is the most advanced one. So, and all the colleges almost they have licenses for MATLAB.
So, what other embedded system you work on? You work on MSP 430 from Texas Instruments.
From Texas, Raspberry Pi is not meant for like highly industrial levels, but this ARM processors, whatever is ARM processors are nowadays very hot. FPGA is very hot. SVGAs are a little bit more advanced, but you can start in an embedded system. I think you start with MSP 430. Mm-hmm. That's what you started in your embedded class.
Yes.
So learn that pretty well. So that's very handy. From TI, most of the TI products, ST products, Atmel products, they more or less follow the same path. They are not too much deviated from each other. So if you learn TI and then you have no experience with ST, it doesn't matter because it's more or less close. So
awesome. Well, let's thank our speaker, folks.